Hello guys, this is Ya Medico from Gandhi Medical College and welcome back to Vision Update. And in this video, we are gonna discuss 5 different questions which are highly conceptual. Okay, and before getting into the video, let me say a few things that we have developed an app called Vision Update, which you can download from the Play Store. And for that, in that Vision Update app, you are available with test series, which is just rupees 499 only, which are made by us, which are collected by us and made by us. Okay, which are highly NCERT restrictive. Okay, make sure you take that test series and make utilize of that. And we are even plan to take over new test series even on YouTube also. So make sure you join all of them. Okay. And okay, Nana, getting into the topic today, let's see our first question. It's our first question. What's given in the question? It's 2,2 dimethyl butene in the presence of alkali, that means KOH, potassium hydroxide with a bit of heat, gives rise to acetones. Okay, Nana. It potassium 2,3 dimethyl butene upon X reaction in the alkali gives rise to 2 acetones anamata. So what would be the probability of being X? Which reagent will be the X? Okay, Nana, what is the X reagent? Okay, come, let's do this. And first talking about this, Nana. See, it is an acid. Basic that this is an acid. When acid reacts with base, it leads to neutralization reaction. Okay, so hence it cannot be our option, right, Nana? And next, going to here, presence of oxygen doesn't make much difference. And going to here, it is not ozonolysis. Okay, Nana? Ozonolysis kaadu. It's not ozonolysis. In order to consider ozone here. Okay, Nana? Ozonolysis takes place in the presence of zinc and CH3COOH, right, Nana? In case if it is what is this, Nana? In case if it is a reductive ozonolysis, right? And if in case it is a oxidative ozonolysis, it's just ZnH2O plus O3. And here also O3. It's oxidative ozonolysis. It is neither of them. So, Nana, it's not ozonolysis. Okay, Nana? It's not ozonolysis. So, third option will be exempted. We have left over with only one option, that is KMnO4. Come, let's see what's the concept here. Okay, now see KMnO4, Nana. KMnO4, which is known as potassium permanganate. We have two important reactions of that in our syllabus. One is acidic and one is basic. Okay, Nana. One is acidic and the other is basic. Acidic reaction in the present KMnO4 in acidic solution gives us acids. Okay, Nana. In basic solution, that too in cold basic solution. Okay, if it is in cold basic solution, and if it is, what happens if it is in, okay, let's divide this, Nana. Let's divide this. If it is in cold basic solution, what is cold alkaline potassium permanganate called? Dilute cold alkaline potassium permanganate called Bayer's reagent, right? Bayer's reagent, which leads to the syn addition of OH minus ions. Okay, which will be leading to the which will be leading to the diols, formation of diols. Okay, it will be leading to formation of diols. Okay, Nana. And if it is hot, as we see in here, okay, in the above one, if it is hot, it will be giving us what, Nana? Aldehydes or ketones. Okay, Nana. This is the basic major difference with that. See, KMnO4 in the presence of acidic medium will be given to acids. We will be giving respective acids. Okay, Nana. We will be giving respective acids. And whereas in case of basic medium, it will be undergoing to cold as well as hot or heat. Bayer's regarding Bayer's reagent, it will be syn addition of all OH minus ions, which will be giving rise to vicinal diols. Okay, vicinal diols. Okay, no. And next, coming to the hot, it will be giving rise to aldehydes and ketones respectively. Okay, I don't guess aldehydes majorly. It has another long method. I guess majorly it's ketones in case of that. Okay, no. It's all about our first question. Okay, I guess you are okay with first question, right? No. Okay, potassium permanganate in the presence of acidic or basic. There are two conditions, acidic and basic. In the acidic condition, it will be oxidizing that and giving its respective acids. That is carboxylic acid. Okay, respect to carboxylic acid, and in the presence of base, it will be divided into two. It might be cold or it might be hot. In cold alkaline solution, it is called as Bayer's reagent. Cold alkaline KMN4 is called Bayer's reagent. In that, it will be underway in addition of OH minus ions, and whereas in hot it will be giving rise to ketones and aldehydes. And it's our next question. No? What is our next question? Next question is, okay, chloroethane. They has given us chloroethane in the presence of alcoholic KOH. What is the function of alcoholic KOH? The function of alcoholic KOH, what is it? Dehydrohalogenation, right? Dehydrohalogenation. Following which mechanism? First of all, following E2 mechanism, right? E2 mechanism. Then it must be following. It must be following no. Zaitsev or Hoffman's rules, right? Majorly Zaitsev we're going to get only Zaitsev here. Okay, no. What is E2 addition? E2 is nothing but the reactions which the elimination reaction which follows second order kinetics. Okay, na? KOH follows E2 elimination. Okay, we do have E1, E2 and E1 CB reactions. Out of that, it will be following E1 E2 reactions, right? Now E2 elimination reactions. It will be following Zaitsev reaction. Zaitsev will nothing but when two alkenes may be formed, the alkene which most substituted one will be the predominating one. Okay, most substituted alkene will be formed. Okay, no, most substituted alkene will be formed. Okay, then what will be our answer here? If we do dehydrohalogenation here, from hydrogen from here, and halogen from here will be eliminated and giving rise to the formation of alkene. Okay, Nana? I'm pretty sure that you are understanding what I want to convey. Okay, Nana? See, this is E2 elimination out of E1, E2 and E1 CB reactions. These three are eliminative reactions. In that, eliminative mechanisms, in that it follows E2 mechanism. E2 mechanisms do involve the elimination of dehydrohalogenation as said, and it follows Zaitsev rules and Hoffman's rules. There are particular Hoffman's rules which are quite opposite to this. It will be least, what will be major, this is a major product, and here least substituted will be the major product. Okay, now least substituted will be the major product. We do have certain conditions called in certain conditions like reagent must be bulky reagent, and in beta position we must have fluorine and all. We have particular few rules and all that will be discussed further and all. Okay, no. Out of that we these are the main basic that we must know regarding Hoffman's rules. Okay, Nana. Okay, I am moving further, Nana. Moving further towards the next question. Next question is pretty interesting, and moreover, Nana, as we are going through that, guys. As we are going through that E2 elimination, we'll be even studying its the case of dehydrohalogenation, tertiary, secondary, and primary, right, Nana? Secondary, tertiary, and primary. And out of all the halogens, iodine will be easily removed. Next, bromine. Okay, Nana? Next, chlorine. This is the ease of the reactions. Okay, Nana? Guys, see, this is first and this is second. Ease of reactions for the tertiary or secondary or primary alkene, and ease of reaction for the halogens here. You must remember that it is regioselective. Okay, Anna. Regioselective according to Say's rules. Okay, Anna. It is regioselective as well as stereoselective. It is regioselective as well as stereoselective. E2 reactions are regioselective as well as stereoselective. Once again, E2 reactions they follow second order kinetics out of E1, E2, E1 CB. These reactions follows E2 reactions. Sorry, E2 elimination, E2 mechanism type of elimination. Out of that, we will be getting SHF as a major product, which is most substituted alkene will be formed. Okay, Nana. And moreover, addition to that, the ease of reaction for that will be the tertiary, secondary, primary alkenes, and after that we will be getting iodine, bromine, and chlorine. Nana. And moreover that, we are concluding with that E2 elimination mechanisms are regioselective as well as stereoselective. Okay, and next going to third question, Nana. Here, a gas has been decolorized. A gas has decolorized the KMnO4. Okay, Nana. KMnO4 has decolorized by a certain gas. Let us call that gas as X gas. Okay, and no precipitate is formed with ammonical plus chloride, and or which of the following gas does not precipitate with the. Okay, we have been asked in two types. It is only single question, but we have been asked in two types. Okay, it doesn't give a precipitate with ammonical plus chloride, and it is a gas, right? So after the observation, we can go right. See, what are all which can decolorize KMnO4? It is a saturation test, right, Nana? Saturation test. Unsaturation test. Okay, Nana. We generally call it as unsaturation test, Nana. Unsaturation test is given by alkenes and alkynes. Okay, Nana. Alkenes and alkynes gives unsaturation test, positive unsaturation test. But what is the second sentence he has given is precipitate is not formed. Alkenes doesn't form any precipitate when react with ammonical cuprous chloride. Okay, Nana. It either forms precipitate with ammonical cuprous chloride, or it either forms precipitate with ammonical silver nitrate. Okay, both of that will not be given. We generally call it as tolerance test and Felling's test and all, right? No. These will not be giving. I mean, tolerance test. This ammonical cuprous, ammonical silver nitrate, whatever the reagent is that, we call it as tolerance test. Okay, no, it is tolerance test. Okay, it is tolerance test is not given by this alkenes, whereas alkynes give both the confirmative test. Okay, no. Okay, so from this alkene must be the answer. Ethane is an alkane, so it cannot be the answer, right? No, it cannot be the alkane as it is an alkane. Methane is also an alkane, cannot give answer. And next, ethene and acetylene. Acetylene is a alkyne, right? It will be giving positive, but he said it doesn't give in the question, so ethane will be our answer. I am pretty sure that you are getting my concept and all. Okay, Nana. Yeah, the unsaturation test is given positive by only alkenes and alkynes. Out of alkynes and alkenes, this so-called cuprous chloride test as well as ammonical silver nitrate test will be only given by alkynes. Due to that, if there is only terminal, it's not like every alkene will be giving this positive. Only terminal alkynes. Okay, only terminal alkynes will be giving this positive test. So for example, R, C double bond O, triple bond O, and H, because this so-called structure exhibits acidic nature, or it also we can also say it as it exhibits nucleophilic nature. Okay, and it works as a nucleophile as well as it divides into minus and plus H plus and CO minus, right? No. This part now acts as a nucleophile. Okay, so that this nucleophile attacks the AgNO3 and gives us a positive ammonical silver nitrate as well as ammonical cuprous chloride test. Okay, Nana. I'm moving further. And our next fourth question is the dehydrohalogenation of neopentyl bromide. What is neopentyl bromide now? This is neopentyl bromide, right? Okay. This is neopentyl bromide. What happens? Neopentyl bromide with alcoholic KOH. It's very simple question, Nana. The same question which we have done before. Okay, in the presence of alcoholic KOH. The presence of alcoholic KOH, what will be doing? It will be dehydrohalogenation. Doing dehydrohalogenation. But what actually happens is, let's go through the step by step. What happens is, it will be giving this first. This first and Br minus. As Sinana, it follows E2 mechanism, right? I just before said that it follows E2 mechanism. Alcoholic KOH form follows E2 mechanism, in which tertiary is stable than secondary is stable than primary. So it is primary, right, Anna? It will be shifting here. This is called methyl shift. Methyl shift in order to stabilize the intermediate. Okay, Anna? What is the intermediate here? Okay. In order to stabilize the intermediate, methyl shift takes place, Nana. After methyl shift, what will be the product? It is tertiary carbocation. Yes, it will be our tertiary carbocation. What happens further? This tertiary carbocation, as it is dehydrohalogenation. Next, the hydrogen will be lost from here, and it will be giving this product now. Okay, we will be getting this as a product. What is this? 1 2 3 4 2 methyl 2 butene, 2 butene. Okay, no, is 2 methyl 2 butene. We have got our answer, right? After it's going E2 mechanism, we are getting this as a product. Okay, Nana. I'm moving further. See, Nana, we'll be moving further. As we move further, we'll be learning more and more. Okay. And next, dehydrohalogenation again. Sorry, dehalogenation here. It's just dehalogenation here. During debromination of meso-dibromo, the major product formed is dehalogenation of vinyl dihalides. Okay, vinyl dihalides. What all we can use here? What all dehalogenating agents, For example, I'll be giving a simpler one, that is zinc in alcohol. Okay, now heat. Zinc in alcohol along with a reflex. We can call it as reflex, or we can call it as heat. What he has given here is meso-dibromo. Okay, meso-dibromo. This is what he has given. This is methyl-dibromobutane. Okay, no. Upon action of any dehalogenating agent, what will be the product formed here? See, Nana, I have just said that. Okay, I have just said that this all undergoes E2 mechanism. Abiding that, whatever the product we formed here will be stereo selective. Okay, it's stereo selective, which means the product which will be formed must be stable. Okay, it's not like you will be forming something or the other. You will be giving cis-butene or trans-butene and all. That's all is the answer. It doesn't work like that. It must be having less hindrance. Okay, most stable form. The only simple concept that you must strike here is stable. Which is most stable will be formed, right? We clearly know that will be from the meso compound will be getting 2. right guys, we'll be getting 2. Either it may be cis or it may be trans. Okay, either it may be cis or it may be trans. Out of which is more stable? Trans is more stable, so automatically this will be the major product formed. Okay, from meso upon dehalogenation. Okay, no. Upon dehalogenation, we will be getting 2, that is cis and trans, out of which trans will be the most stable, cis will be the least stable. So the minor formed is cis and trans will be the major product. Okay, these are the 5 questions, I guess, which we must have been which we wanted to say. These are the most important questions, Nana. Okay, highly conceptual. I hope you all got this. These concepts and all. If you don't get, let me know again. We'll be trying it again in the next video. Okay, thanks for the watching. And if you need any more topics on this, any topic, you just comment it. We'll be explaining that in detail.